The first question we are going over is homework 03, number 12, and it tells us that our f of x is mx plus b, where m is greater than 0. Our L is equal to m over 2 plus b, our C is 1/2, and epsilon is equal to k. And based on the definition of a limit, we know that f of x is defined on an open interval about c, and for every number of epsilon greater than 0, there is a corresponding number delta greater than 0. So based on the definition of a limit, we know that it's set up as limit as x approaches c of f of x equals L. And so setting up our equation like that, we know our limit is as x approaches 1/2 of the function mx plus b is equal to m over 2 plus b. And based on the limit of a definition, we know that these things need to be held true. So the first part of our question is, what is the open interval, or basically our bounds? And our bounds of our functions is based on e, or epsilon, and we know that epsilon is k. So epsilon is the absolute value, so that means that epsilon can be either positive or negative, which means we can have a negative epsilon of our function, which is going to be mx plus b minus m over 2 plus b less than our positive epsilon. And it looks like that because the definition of a limit where f of x minus L is the absolute value of f of x minus L is less than epsilon. So we need to get x by itself to find the values of x. So we know that if you distribute this negative, b is going to cancel out. So we're going to be left with mx minus m over 2 and keep our bounds. And then we're going to add m over 2 to both sides. So we're going to have m over 2 minus epsilon over here with mx in the middle, and m over 2 plus our positive epsilon, and divide by m. We're going to have x equal to 1/2 minus epsilon over m, which is less than x, which is less than 1/2 plus epsilon over m. And because our epsilon is k, we can basically fill in all of these with k, because it tells us that as a given. So our bounds, our open interval rather, is 1/2 minus k over m to 1/2 plus k over m. And these are our bounds. And that answers the first part of this question. So in the first part, we just found out that our bounds is 1/2 minus k over m to 1/2 plus k over m. And so now we're trying to find delta. And we know to find delta, delta is equal to the minimum of the absolute value of our bounds, which would either be 1/2 minus k over m, or 1/2, the absolute value of 1/2 plus k over m. Which is less than delta. And so to find delta, we're going to keep that, I'll just rewrite it. The absolute value of x minus c is less than delta. And so we know that our x has to be one of these minimums. So let's just try the first one, 1/2 minus k over m. And plug it in here, it's minus 1/2 because c is 1/2 and that's a given. And 1/2 minus 1/2 is going to cancel out. So we're going to get negative k over m. And our other one is going to be 1/2 plus k over m, and then minus 1/2. And once again, this is going to cancel out, but we're going to be left with positive k over m instead this time. And so because delta is a minimum, it's either which one is smaller, negative k over m, or positive k over m, and it's going to be this one. And because this is our minimum now, we take the absolute value. And so that's going to be k over m. So our value of delta is equal to k over m. And that's how we do number 12.